So, transmissions, how do they work? I don't know, but we have choices. This here is the factory gearbox from this car. This is the E250F, which is used in the 96 to 2000 RAV4s exclusively, no other cars. That is an E153. Well, it's not, but for the purposes of this discussion, that's an E153. And I'm going to discuss the differences between the two and explain why I'm sticking with them. So what exactly am I doing with these? So this is this is an E53, but for the point of this, it's just effectively an E153 as well. This is what's called a narrow case transmission. If you watch Frankenstein Motorworks, a good portion of you probably do, you're going to be familiar with this as a concept. The difference between what he has and what this is a wide diff, which means it's all-wheel drive capable, right? Which is what he was talking about. So it has the output shaft sticking out there. Well, this piece here, which is the mid case, is what differentiates the two transmissions. This is different from what Mark had because, or this is different because this is a wide diff. If you notice, these heights are the same. Internally, they only differ from the right above the shift tower up. So I think I can shove this diff in a wide case if I decide I need more strength. So a couple things keeping me on the narrow diff, or narrow case wide diff platform is the gear ratio. So this has a 3.833 first gear and a 4.933 final drive, which means that I have about 19-to-1 reduction in first gear. The wide case, the shortest factory diff is, or final drive is 4.285, which I have a spare of that. But then the first gear is 3.538, I believe, which ends up being about a 15-to-1 reduction at the wheels. So it's much taller gearing than this, and especially if I'm going to bigger tires on this car, I wouldn't want to reduce gearing any further. And another thing is, if I hypothetically made a longer final drive for that, or if I figured out, ultimately what I'm testing right now is, can I fit this diff in that transmission? And where is the ring gear height? If it's at the right height, I could make a custom output shaft for that and get the 4.933 in that transmission. But then one thing that kind of sucks is this fifth gear is out of a diesel Avensis in Europe, which is a 0.690, which is great on the highway. Factory, this came with a 775 fifth gear. But the 690 is perfect, and that's limited, the wide case is limited to 0.731, which isn't the end of the world, but I would be taking a step back on like daily ability. So I'm at a point where I'm looking to get a custom output shaft and ring gear made for this transmission. If I'm going to be making a custom one, I'm going to want to upgrade over that, keeping the module the same on the gears. It ends up being the next step up above 4.9 is 5.16 to 1. I'm looking at getting a couple of those made, and I'm gonna need a couple sets. So if you are interested in getting a 5.16 final drive for an E153, let me know. You know, if you guys race on them, and you want shorter gears, that's perfect. If you guys are like me and building off-road cars with them, then that's also good. And with that, this is going to be an upgrade to both of my cars. I'm getting a .651 fifth gear made, which is a step above the 690 for the wide case, the later series wide case. The 93 Plus MR2s, the 92 Camry, the 97 Camry, a couple others, the GT4s. So that way, in fifth gear, it'll be about the same for me as this setup, but I'll have a better first gear reduction. I may be looking at a custom input shaft for these too, because 3.538 is not fantastic. I'd like to go at least 3.833, potentially higher. That'd be cool. Then I could get well above 20 to 1 reduction. This transmission specifically is getting torn apart for the gear set, the 3625 final. It's going to my friend in the UK who just can't find them over there. So I'll have two spare E153s effectively. So I might as well, you know, give it a shot in terms of building a custom transmission then. I guess I gotta take this one apart, see if stuff swaps over like I expect it to. So the E250F that came in the car is a narrow case wide diff transmission. We use that term wide diff. It doesn't necessarily mean something. I don't know if the diff from this transmission will fit in a wide case. So there are a couple things we need to check. First thing, the oil pump drive. This is the one that came out of the 250. This is the one that came out of the 250. This is the one that came out of the 350 or 53. E53. The gear height is the same. It appears to have the same nominal dimension from here to the gear, and it appears the hex is the same size. So it should work. More important business. This is the diff. It's huge. So I need to make sure this actually fits in the wide case before I can do anything with the output shafts. Now I can put the wide diff in without killing myself. Okay, well that's big news. It spins and it clears everything. The important thing is it's going to land at the same height as the normal output shaft. And it's hard to say. It seems like the answer is yes. Yeah, it is. Ow. So it would take a custom output shaft, but I could put this final drive in this transmission. Oil pump drive fits just fine. It also spins, not a big deal. It's kind of expected. Good to know. Well, what this means for me is that I could build, with a custom output shaft, I could build a wide case to support my needs. I wouldn't be able to go larger than the 4.9, I think. One thing I've also been curious about is, can I put the narrow case on the wide bell, or the other way around? That's the wide bell. Yeah, it fits. Well, looks like it would just take replacing this with a narrow case version to work. That means when I hypothetically build this wide case, I can take the bell housing from the 250, because it's newer. It has a couple extra bolt holes that fit on the AR versus the E53. The latest E153 should have the same bell housing as the 250F. Well, given what we've found out between these, I need to replace the second gear on this transmission, but they're back ordered for, you know, who knows how long. But I really like to get moving on this again, so I'm actually going to strip this transmission down, take all the internals out, and then use that to mount the motor back in the car, because all the important bits are dimensionally the same for me. So it'd actually be perfectly fine for me to use this. And the rain's picking up again. Alright, so if you guys remember last time we talked about transmissions, I brought up this reverse sensor and how it doesn't quite clear the manifold. Or a couple things on the transmission didn't quite clear the manifold. So I've went ahead and remedied those. The first thing were those bolt holes for the four-wheel drive actuator. Just cut those off just with a grinder, no big deal. The other thing, like I just said, was this thing. So my solution to this, I tried running it just without the washer, see if it got low enough where it would clear. It doesn't. I had a broken one where the connector was broken off, but the pins were still there, so I figured that would be okay. Tried that, still didn't fit. So then what I've done now is I kind of cut along that seam, and I've invented this guy. Just popped that top metal cap off. So I will have to epoxy this. My plan is to solder onto those wires, epoxy everything in place, and then have a connector elsewhere that I can just then plug into the harness. So just to show that it fits, it'll go a little bit further down too once I actually torque it, but this is fine for a test. And just barely clears. I have honestly maybe a millimeter of clearance, so that should be enough room to solder and epoxy, so shouldn't be a big deal. And that's, like we've talked about, the what's actually moving to turn the light on to know that the car's in four-wheel drive. So I wanted to keep that just to know that it's working properly. This thing has been the source of my nightmares for about a month now. This was such a pain to get rebuilt, simply because this car is so old. It actually uses some older E-Series parts, and the parts I needed to replace weren't available anymore. I needed a hodgepodge parts from different model years, different cars, to just figure out something that worked, period. So I know I said I was going to do a full in-depth video on the rebuild process of this, but I'm not going to do that, just because of what this entailed. I am going to finish a blog post. This might already be up by the time this video is up, of exactly what I had to do to this to get the parts I needed. But one modification that I am doing that I wanted to document on video is taking the input shaft rear bearing and de-shrouding it. So the OEM rear main bearing for this transmission is from NSK, and if you look up this part number, I don't think it actually exists, but the closest ones actually have a RPM limit of like 6,000 or 6,500. In fact, Toyota is exceeding that on some of the stock applications for this. But especially with the 2AR revving up to 7,200, I'm well exceeding that. But the non-sealed version of the same bearings end up having a way higher rev ceiling. So I'm thinking, Mark did this with the EB. I'm gonna remove these, and based on the analysis that I've done, it should get enough oil still to be to circulate. So now, instead of having seals in the way, instead of being greased, this will actually get oil circulation through the transmission. So that should just increase reliability, hopefully. If I see bearing failures, I'll be documenting those. But I suspect this should end up increasing reliability. This is actually the old bearing that came out of the transmission. As far as I know, this is original to the car. So this has approximately 200,000 miles on it. And it doesn't look worn necessarily, but there are signs of wearing. But I would be perfectly comfortable reusing this if I didn't already have a new one to go in. So I am gonna stick this on the shelf. I don't know, maybe I'll use it again someday. So to kind of clarify what I was talking about, I wanted to take apart the new bearing to compare them and explain what actually is happening. All right, this demonstrates exactly what my issue is. So when the bearing's brand new, it's greased, and that grease is sealed in with those bearing seals. I did nothing to this bearing other than remove it from a used transmission. Well, used, it's my own, but it's not new. The issue that's happening is when these get hot, especially at super high RPM, this grease melts and it leaks out of those seals, just a small amount. And because of the way those seals are, there's no way to get new oil in. So eventually these just kind of run dry or on some vapors. And that seems to work okay, but I would be a lot more comfortable if it just had a fresh supply of oil. So we'll throw this in now and see just how it goes long term. Well, since the transmission was all figured out, I threw it back on the engine and threw it in the car for the last time, I hope. So all the suspension's back in, the car's on the ground. So all that I really have left on this is to finish the wiring and deal with the exhaust. The exhaust should be pretty straightforward. I need to take this header and grind it, surface grind it, because the flange is really warped, eBay spec, whatever. As for the wiring, I've actually already done most of it. I did that while I was out of the car. I didn't want to show that on camera because what I'm doing wouldn't necessarily apply to anyone else unless they're doing this exact same thing, which I don't really expect anyone else will. Basically what I did is I got the Scion TC engine harness and the RAV4 engine harness. I cut all the sensors off of the engine on the RAV4 and stripped it down to just being the transmission leg of the harness. So stuff like the starter, the reverse and four-wheel drive sensors, and the four-wheel drive VSV actuators, and then the battery cable, as well as everything that goes inside the car. So the starter relay and all the ECU plugs, the speed sensor that goes in there, everything like that. And I just kind of tie them together. And crazy enough, with Toyota being Toyota, this was the fuse box connector on the Scion TC engine harness. And I did not even realize this till I was done wiring. It's the same plug. It's literally the same connector. Which, if you're familiar with the MR2 Spider version of this swap, they experience the same thing. So I guess this RAV4 is somewhat similar to the MR2 Spider in terms of the wiring and stuff. And in fact, not only that, but the ECU integration, sorry, not the ECU integration, the chassis side integration for signals also has the exact same connector. So this is stuff like fuel injector power, ignition power, stuff like that. So that made it really easy, since for a lot of this, they land in similar locations, so I could just take the pin out of one connector and put it straight in the other. So I didn't really have to do much in terms of new crimps. Now, some of the more intense wiring shenanigans I had to accomplish. So all of the 2AR cars have the ECU mounted in the engine bay, usually right by the intake, which is here typically. And while that works, I didn't necessarily want to do that because I expect this engine to see a lot of water and mud and stuff, so I just wanted to keep that in the cabin if possible, which is where it is from the factory. Issue being that since all of the engine computers end up being over here, that's where the ECU plug is. The RAV4, typically speaking, all of the wires route through right under the battery tray. There's a hole. So I wasn't looking forward to making new holes in the firewall, which I'm not opposed to, but I just wanted to avoid it if possible. So I decided my best course of action would be to extend all the ECU wires. So I got them all the way over here. Surprisingly, I only ended up having to extend about 20 wires or so. Because if you think about it, around here, it's kind of mirrored. So if I could, basically only had to extend everything past this side of the harness, which is the two cam sensors, the coolant sensor back here, these two coil packs, and the throttle body motor. So pretty minor overall, and that gave me an excessive amount of length over here. So the only thing I have left is the MAF sensor and the purge solenoid, because I'm not entirely sure where I'm going to have those landing yet, the intake and stuff. So I'm leaving these attached to the ECU for now, and I'll extend them when I have the intake mounted. The last major thing to deal with was the AC. I don't even remember if I talked about this on video before, but I'm actually using a V6 Tundra compressor, so the 1GR FE, and the two reasons I went with the Tundra compressor. The 2AR compressors are variable displacement, which means they can have a more constant flow of refrigerant rather than a clutch PWMing on and off. So they take slightly more complicated electronics, so I would have had to wire in a Camry or TC or RAV4 AC amplifier to control this. As it turns out, the 2AR and 2GR compressors share a bolt pattern, so the common thing to do with the 2GR swaps is to run a Tundra compressor because it's single displacement, so it's just a clutched AC. And for the 2GR, it's easy because the connector is the same. On the 2AR, they're different. So these are the two connectors for the AR. Then the Tundra has this little triangle one, this guy. So I just had to add this and just wire that to the correct locations. Not a huge deal at all, just a minor thing to deal with. Then in the same area, really minor thing, common on any engine swap. The batteries on the 2AR cars are over here also. So the alternator wire goes through the harness all the way around to the battery. My battery's just right there. Normally right here. So I just had to pull that out of the harness and shorten it and plug it right into the battery. This I know I didn't show on camera, but if you guys remember from earlier, the four-wheel drive sensor clearance with the intake manifold, what I ended up doing was cutting the connector off, soldering wires to the pins, and then extending the harness, and I just mounted it here. I made a little 3D printed bracket. I'll insert pictures of these. If you follow me on Instagram, you would have seen them. So I just mounted it there for ease of convenience. I ended up using a Denso fuel injector connector. I didn't use this stock connector. This is what they would have looked like, because there's no female side of, or there's no male side of this. This is the female side. So the ejector, it's still 2 pins, and I can get both sides because people make extensions for adapters and whatnot. Another minor thing, Again, common on 2 GR swaps. This 3-pin coolant sensor, normally the 2AR has 2 pins that feeds right into the ECU. Then the ECU outputs temperature to the dash over CAN. This being an older car has a physical sensor leading straight to the dash. So the 3 pins gives 2 to the ECU, and then 1 has the output straight to the dash. So there's the same sensor I use for my 2GR MR2. So again, just a small wiring change to put that on. So realistically speaking, all that's left for the swap is fabricating an intake, an exhaust, tidying up the wiring, and making a foot-long fuel line. And then it's pretty much ready to go. And of course there'll be continual issues, upgrades, problems to solve. So I'll try to keep making videos on those when they arise. Chassis side, this still has some work left on it. I still have to finish brakes and a couple things left on the suspension. But those aren't relevant to the swap, so I didn't cover those on video.